Hello class, this is Adam Ward and I want to work with you on an example applying the Bernoulli equation. In the given problem you've got two jets of water, one falling freely from a tank where I've drawn the number 2, and the second being pushed out of a pressurized tank where I've drawn the number 1. And these two jets intersect one another 20 feet off the ground, and the question is what height, h, would be required for the jet to stay at 20 feet off of the ground surface. So to solve this problem we're going to apply the Bernoulli equation to relate pressures, elevations, and velocities to one another. And the first thing we'll do is apply the Bernoulli equation between point 2, labeled on the plot, and point A, the stagnation point in between the two jets of water. And so I've gone ahead and written down our known pressures, velocities, and elevations. Notice PA is unknown. In this case, we're not assuming the pressure is 0 because this is not a free jet in the atmosphere. These are two jets intersecting with one another, and so they're pushing against one another. Therefore, there is a pressure in between them, even though immediately outside of either nozzle you could make that free jet assumption. It's not valid at point A. So with those written, we can write the Bernoulli equation now between point 2 and point A. We can apply some assumptions to zero out a few of our terms. And we end up with the equation shown here. H plus 20 feet is equal to the pressure at A over gamma plus 20 feet. And we can simplify that out to H is the pressure at A divided by gamma. Now, we can also apply the Bernoulli equation from point 1 to point A. So I've gone ahead and written out our known and unknown values. Velocity of 0 in both cases. Elevations are both known, and we do know the pressure at point 1 of 25 psi gauge pressure. We'll write our full Bernoulli equation to relate point 1 and point A, which share a streamline, so our Bernoulli equation can be used. Zero out the terms that we can, and I'll reorganize the equation now to set it up as the pressure at A over gamma equal to the pressure at 1 over gamma plus the elevation of point 1 minus the elevation of point A. And as you may suspect, the reason I've done this is that you can now relate the two Bernoulli equations that we've written, as shown in orange here. The unknown quantity equal to the pressure at 1 over gamma plus and minus the elevations respectively. Plug in values and making sure that we recognize pressure was given in psi, and so we've got to multiply that by 12 square inches squared per 1 square foot. Plugging in values, I end up with a final calculation of h equal to 45.7 feet. I hope this helps you see how the Bernoulli equation applied twice in one problem can solve the problem for us. Thank you.